Explain the desirable thermodynamic properties of and environmental safety aspects of alternative refrigerant. Toxicity. It is obviously desirable that the refrigerant have little effect on people. Inflammability. Although refrigerant are entirely sealed from the atmosphere, leaks are bound to develop if the refrigerant is inflammable and the system is located where ignition of the refrigerant may occur. A great hazard is involved. Boiling point. An ideal refrigerant must have low boiling temperature and at atmospheric pressure. Freezing point. An ideal refrigerant must have a very low freezing point because the refrigerant should not freeze at low evaporator temperatures, evaporator and condenser pressure in order to avoid the leakage of the atmosphere air and also to enable the detection of the leakage of the refrigerant. Both the evaporator and condenser pressure should be slightly above the atmosphere pressure. Chemical stability. An ideal refrigerant must not decompose under operating conditions. Latent heat of evaporation. The latent heat of evaporation must be very high so that a minimum amount of refrigerant will accomplish the desired result. In other words, it increases the refrigeration effect. Specific volume. The specific volume of the refrigerant must be low. The lower specific volume of the refrigerant at the compressor reduces the size of the compressor. Specific heat of a liquid vapor. A good refrigerant must have low specific heat when it is in liquid state and high specific heat when it is vaporized. Viscosity. The viscosity of the refrigerant, both the liquid and vapor state, must be very low as improved heat transfer and reduced pumping pressure. Corrosiveness. A good refrigerant should be non-corrosive to prevent the corrosion of the metallic parts of the refrigerator. Odor. A good refrigerant must be odorless, otherwise some foodstuff such as meat, butter, etc. loses their taste. Oil solvent properties. A good refrigerant must be not react with the lubricating oil used in the refrigerator for the lubricating the parts of the compressor. Thermodynamic and thermophysical properties. Suction pressure. At a evaporator temperature, the saturated pressure should be above the atmospheric for prevention of air or moisture or and non-condensable gases ingress into the system and ace of the leak detection. Higher suction pressure is better as it leads to smaller compressor displacement. Discharge pressure. At a given condenser temperature, the discharge pressure should be as small as possible to allow lightweight construction of compressor, condenser, pipe, etc. Pressure ratio should be as small as possible for high volumetric efficiency and low power consumption. Latent heat of vaporization should be as large as possible so that the required mass flow rate per unit cooling capacity will be small. Isentropic index of compression should be as small as possible so that the temperature rise during compression will be small. Liquid specific heat should be small so that degree of subcooling will be large leading to smaller amount of flash gas at evaporator inlet. Vapor specific heat should be large so that the degree of superheating will be small. Thermal conductivity. Thermal conductivity in both liquid as well as vapor phase should be high for the higher heat transfer. Viscosity. Viscosity should be small in both liquid and vapor phase for smaller frictional pressure drops. Environmental and safety properties. In fact, at present, the environmental friendliness of the refrigerant is a major factor in deciding the usefulness of a particular refrigerant. The important environmental and safety properties are Ozone depletion potential ODP. According to the Montreal Protocol, the ODP of refrigerant should be zero. That is, they should be non-ozone depletion substance. Refrigerants having non-zero ODP have either already been phased out or will be phased out in near future. Since ODP depends mainly on the presence of chlorine or bromine in the molecule, a refrigerant having either chlorine or bromine cannot be used under the new regulation. Global warming potential. Refrigerant should be have a low GWP value as possible to minimize the problem of global warming. Refrigerant with zero ODP but a high value of GWP are likely to be regulated in the future. Total equivalent warming index. The factor TEWI considers both direct due to release into atmosphere and indirect though energy consumption contributions of refrigerant to global warming. Naturally, refrigerant with as a low value of TEW preferable from global warming point of view. Toxicity. Ideally, refrigerant used in a refrigeration system should be non-toxic. However, all fluids other than air can be called as toxic as they will cause suffocation when their concentration is large enough. Thus, toxicity is relative term which becomes meaningful only when the degree of concentration and time of exposure required to produce harmful effects are specified. Some fluids are toxic even in small concentrations. Some fluids are mildly toxic. They are dangerous only when the concentration is large and duration of exposure is long. Some refrigerants such as CFCs and HCFC are not toxic when mixed with air in normal condition. However, when they come in contact with an open flame or electric heating element, they decompose forming highly toxic elements. In general, the 3 degree of hazard depends on amount of the refrigerant used versus total space, type of occupancy, presence of open flames, odor, or refrigerant and maintenance of condition. Flammability. The refrigerant should be preferably non-flammable and non-explosive. For flammable refrigerants, special precautions should be taken to avoid accidents.